Okay, folks, welcome to the second video for Chapter 6 of your McGraw-Hill Geometry textbook notes. This video is still in Section 6. We're talking about the other shape, other than trapezoids, that appears in Section 6, and that shape is the kite. A kite is a quadrilateral with two pairs of consecutive congruent sides. So in other words, AD and AB are congruent, BC and CD are congruent. So the kites have four properties that we're going to use in algebraic problems. The first property is that the diagonals are perpendicular. And what I mean by that is that AC is perpendicular to BD. Which means if I labeled this middle point here E, all four angles in this picture that have a vertex at point E are right angles. Okay, the next property deals with the short diagonal only. The short diagonal, that's the diagonal that connects B to D, is being bisected by the long diagonal. So BE and ED are congruent. Now please note that that is true, but the other is not. E is not the midpoint of AC. E is only the midpoint of BD. The third property says exactly one set of opposite angles are congruent. Those are the angles at each end of the short diagonal. That would be angle ABC and angle ADC. Those two angles are congruent angles. And then finally, the long diagonal is an angle bisector of the angles at each end, which means angle BAD is being cut in half by AC. So angle BAC is congruent to angle DAC. And the same is true at the other end. Angle BCA is congruent to angle DCA. So those are our four properties for a kite. Now with kites, we are not going to do problems on the coordinate plane. We are only going to do problems based in algebra, based on algebraic properties. So let's do a few examples of those. Here's the first. It says ABCD is a kite. If BC equals 10 and BE equals 6, find the length of CE. Well, this requires us to recognize the property that says BD and AC are the diagonals of a kite. They must be perpendicular to each other. And what that allows us to do is it allows us to focus in on this shape here, BEC, which is a right triangle. And in any right triangle, we should know that the length of the hypotenuse squared is equal to the sum of the squares of the legs. The Pythagorean Theorem applies. So in this case, that would be 6 squared plus CE squared equals 10 squared. So that would be 36 plus the length of CE squared equals 100. We would then subtract 36 from each side of the equation, which would give us CE squared equals 64. And then to get rid of the squared on CE, we would take the square root. So CE would be equal to 8 units. Okay, that's the first problem type, our length problems based in the Pythagorean Theorem. The second problem here says Fghj is a kite. Find the value of x. So in this picture, you'll notice there are no diagonals. But if we drew the diagonals in, FH would be the short diagonal. And we said that the angles at each end of the short diagonal must be congruent. So when we look at this picture here, which I just moved it a little bit, so let me get it back where it's supposed to be, angle F and angle H have to be congruent, which means that angle H is also x degrees. Now the reason why that thought is useful is because all kites are quadrilaterals. And back in section 6-2, when we talked about parallelograms, we said the sum of the angles of any quadrilateral, in this case angle F plus angle G plus angle H plus angle J, in any quadrilateral, those have to add up to 360 degrees. So we plug in what we know here. Angle F is x degrees, angle G is 128 degrees, angle H is x degrees, and angle J is 72 degrees. And we've got ourselves an equation that we can use to solve for x. We combine like terms, giving us 2x plus 200 equals 360. We subtract 200 from each side of the equation, which gives us 2x equals 160. And then we divide by 2, and that gives us that x has a value of 80. All right, so at this point, you've seen the only two examples, the only two problem types that you're going to see. So you should pause the video and try the remaining few examples in your notes, and then resume the video and see how you did. So the example at the bottom of the page here says WXYZ is a kite, find the length of ZY. Now we do not need all of the information in the picture because we need to realize once again that angle YPZ is a 90-degree angle, which allows us to focus in on a right triangle and set up the Pythagorean Theorem. 8 and 24 are the legs. We're being asked to find the hypotenuse. A squared plus B squared equals C squared. So we plug in those numbers. That would be 8 squared plus 24 squared equals the length of ZY squared. 8 squared is 64, 24 squared is 576. Then we would add those together. That would be 640. That's great, but we don't want ZY squared, we want ZY. So we take the square root of each side. Now in your algebra class, you should have learned how to reduce roots, but if you haven't, your calculator is fully capable of reducing that root for you. At least the ones we use at our school are. What you need to realize is that the square root of 640, while it is not a perfect square, it is divisible by a perfect square. It is 64 times 10, which means the answer we're looking for, the square root of 64 is 8, times the square root of 10 units would be the length of ZY. Okay, on to the next example. Here we have a ABCD, which is a kite in the upper right-hand picture. It says if the measure of angle BAD is 38 degrees and the measure of angle BCD is 50 degrees, find the measure of angle ADC. So what I'm going to point out is that we do not need the diagonals in this picture, okay? So if we look at this picture here, and I'm going to use my ability to write over the picture in white, we don't need the diagonals to solve this problem, okay? So we are going to look at this kite, and in our brain we need to erase the diagonals from our memory and not even consider them. We need to consider the picture without the diagonals because the measure of angle BAD, that's this angle down here, is 38 degrees. And the measure of angle BCD, that's this angle up here, that is 50 degrees. Now those are also the endpoints of the long diagonal, which means the remaining two angles are the same angle. We don't know what that measurement is, so let's call it X. Once again, if we add up the four angles of any quadrilateral, any kite, they must add up to 360 degrees. Combine like terms, 2x plus 88 equals 360. Subtract 88 from each side of the equation. Gives us 2x equals 272. Divide by 2. And we get that x, which is equal to the measure of angle ADC, is what? Excuse me. Did I do that right? That doesn't seem right. Let me grab a calculator real quick, check my math there. So we did 360 minus 88 was 272 divided by 2. There we go. I did do that right. 136 degrees. All right, then finally we have BT equals 5 and TC equals 8. So once again, we need to realize that this is a right angle where the diagonals are crossing, which means we are going to focus in on only one of those right triangles. In this case, triangle BTC. And I know what you're thinking, Mr. Wills, D is not involved in that picture. Well, CD and BC are the same length. So if we can find BC, which I'm going to mark with an X, we've also found CD. TC is 8, BT is 5. Pythagorean Theorem, 5 squared plus 8 squared equals X squared, because that's our hypotenuse, so that's the C, these are the A and the B. So that's 25 plus 64 equals X squared, meaning that X squared is 89. Then we would take the square root. Well, the square root of 89 does not reduce, so BC, which is X, is equal to CD, is equal to the square root of 89 units. So that's it for kites. That's it for Chapter 6. Thank you very much for your time and attention. Good luck on your homework.